AMI Day 5, Trig functions redefined. Recall that we defined trig functions in regards to right triangles, sine, cosine, tangent, and then we define the reciprocal trig functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and tangent is the reciprocal, or cotangent is the reciprocal of the tangent. We're going to use those definitions for a second. We'll look first at this equilateral triangle. And if you recall, an equilateral triangle has also three equal angles, each 60 degrees. If I drop this altitude in an equalateral triangle also becomes a perpendicular bisector to the opposite side. That makes this side of the smaller triangle 1/2. That makes this angle, it's also an angle bisector from the vertex. That makes this angle 30, and so that makes this triangle a 30-60-90 triangle where the one leg is 1/2 and the other leg is 1. I'm going to draw that triangle off to the side here. So we're going to use it here in a few minutes. If I can find this side, I can identify the sine of 60 degrees and the cosine of 60 degrees, the sine of 30 degrees, and the cosine of 30 degrees using the right triangle definitions that we've had. So here, if I call this side x, then because of the Pythagorean theorem, we know x squared plus 1/2 squared equals 1 squared, or just 1. 1/2 squared is 1/4. And if I subtract 1/4 from both sides, I get x squared equals 3/4. And if I take the square root of both sides, I'll see that x, in this case, the length of this leg of the right triangle, is the square root of 3 over the square root of 4 or the square root of 3 over 2. So the side of the triangle is the square root of 3 over 2. Using our ratios in our SOHCAHTOA, that tells me that the sine of 30 degrees is 1/2 over 1, or just 1/2. The cosine of 30 degrees is the square root of 33 over 2 over 1, or just the square root of 3 over 2. The tangent of 30 degrees is 1/2 divided by the square root of 3 over 2. And we know we multiply by the reciprocal when we divide fractions to get 1/2 times 2 over the square root of 3. The 2's cancel, leave us 1 over the square root of 3. And I'm going to rationalize that denominator by multiplying square root of 3 on top and bottom. And that makes the tangent of 30 the square root of 3 over 3. And now you also know that the secant is just reciprocal of the cosine, so we can flip that and rationalize the denominator to get the secant of 30. The cosecant is the reciprocal of sine 30, so we can simply flip that and get the cosecant is 2. The cotangent is the reciprocal of 30, so we can flip this and rationalize the denominator and get the cotangent of 30. Let's also find sine, cosine, and tangent of 60 while we're here. Sine of 60 is square root of 3 over 2 over 1. Cosine 60 is 1/2 over 1. And the tangent of 60 is the square root of 3 over 2 divided by 1/2. And again, multiply by the reciprocal, it's square root of 3 over 2 times 2 over 1, the 2's cancel, and that makes the tangent of 60 simply the square root of 3. And we can flip these to get the reciprocal functions as well. The important thing is we've found exact values for sine, cosine, and tangent for 30 and 60 degrees. We're going to use that in a few minutes. Oops, should have extended that down here. Now, let's do the same thing using this 45-45-90 triangle over here to find a sine, cosine of 45. This is a 45-45-90 triangle where the hypotenuse is length 1. A 45-45-90 triangle is an isosceles triangle, meaning the two legs of this 90-degree triangle are going to be congruent. So if we let each one of them equal x, we can see that x squared plus x squared equals 1 by the Pythagorean theorem, or 2x squared equals 1. X squared must equal 1/2. And that makes x the square root of 1, which is just 1, over the square root of 2. We're going to rationalize that denominator and see that x equals the square root of 2 over 2. And we can use this to identify the exact value of the sine and cosine and tangent of 45 degrees. Using that triangle, sine 45 is going to be square root of 2 over 2 over 1, or just the square root of 2 over 2. Cosine 45 is going to be the square root of 2 over 2 over 1, which is just square root of 2 over 2. And tangent of 45 is going to be the square root of 2 divided by the square root of 2. That's just 1, because anytime we divide something by itself, we get 1. That's important for what we're going to do in a minute, because for now, what we're going to do is redefine the sine and cosine. You remember in class we did this the other day. We found sine of certain angles could be negative, positive. We couldn't get those things when we defined sine and cosine in terms of right triangles. But now that we know that angles can be bigger than 180 or bigger than 90, we can say cosine of, let's say, 120, and see that that gives us a negative number. If we did the sine of 240 degrees, that gives us a negative number. So we need some definition to figure out why we're getting these signs where we can have sine and cosine equals 0 and negative numbers. From now on, forevermore, for the rest of your life, your kids and grandkids, for the rest of eternity, we're going to define the sine of an angle theta as its y coordinate on the unit circle. And we're going to define the cosine theta as the x coordinate of the angle theta on the unit circle. So how does that relate to what we just did? Let's remember these values and these triangles, because I'm going to move now to a unit circle. And recall the unit circle centered at the origin with radius 1. So if I make this the point 1, 0, this is the unit circle. That makes this the point 0, 1. That makes this the point negative 1, 0. And that makes this the point 0, negative 1. I've also split this because this is a 90-degree angle. I'm going to rotate like we did the other day. Let's look first at this 30-degree angle. This is 1/3 of the way to 90. That makes that a 30-degree angle. And if I look at this leg drop down to meet the x-axis perpendicularly, I have a 36 or 30, 60, 90 triangle. The hypotenuse is 1. We just created a 30, 60, 90 triangle with hypotenuse 1, and every 30, 60, 90 triangle with a 1 as a hypotenuse is congruent. So that means all of these other measures also hold on this. So this leg is 1/2, and this leg is the square root of 3 over 2. That means the coordinates here, the x-coordinate is the distance a point is from the y-axis, so this travel horizontally will be the square root of 3 over 2, and the y-coordinate is 1/2. The sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3 over 2. We just proved that with the triangles. Now we can look at another 30, 60, 90 triangle here. If this is 30, then that means this is a 60-degree angle. That means this is a 60-degree angle, and the hypotenuse is again 1. So that means this side is 1/2, and this side now is the square root of 3 over 2 because of this triangle. Across from the 60-degree angle, square root of 3 over 2. Across from 30-degree angle is 1/2 when the hypotenuse is 1. And that makes the x-coordinate of this point 1/2, and the y-coordinate the square root of 3 over 2. And look what we found a moment ago. The sine of 60 is the square root of 3 over 2, and the cosine of 60 is 1/2. This is getting a little cluttered now, but I want you to look now at this 45, 45, 90 triangle. Now, this angle is 45. This angle then is 45 if this meets perpendicular. The hypotenuse is 1. We just created a 45, 45, 90 triangle with hypotenuse 1, and that made the other legs square root of 2 over 2. So this side is the square root of 2 over 2. This side is the square root of 2 over 2. That makes the coordinates of this point the square root of 2 over 2 and the square root of 2 over 2. The sine of 45 degrees is the square root of 2 over 2, and the cosine of 45 degrees is the square root of 2 over 2. Now, we can use symmetry in a circle to get all of these other sines and cosines on the triangle, or on the unit circle. First, let's label the angles. We have the 0-degree angle here. This on the circle, we're done with the triangles. Let's move to here. Let's move to a new circle. If this is 0, 30 degrees on the circle, 45 degrees on the circle, 60 degrees on the circle, and 90 degrees on the circle, and we said this is the point 1, 0. This is the point square root of 3 over 2, 1/2. The point square root of 2 over 2, square root of 2 over 2. And the point square root of 3 over 2. Oh, sorry. This is 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. And this is the point 0, 1. So the sine of 0 is 0, the sine of 30 is 1/2, sine of 45 square root of 2 over 2, sine of 60 is the square root of 3 over 2, and sine of 90 is 1. You can confirm those on your calculator. The cosine of 0 is 1, cosine 30 square root of 3 over 2, cosine 45 is square root of 2 over 2, cosine 60 is 1/2, and the cosine of 90 is 0. If we look across here, we can finish this circle out with the angles like we did in class the other day, and use the symmetry to calculate the sine and cosine for all of these angles. Going in the counterclockwise direction, the positive direction, this is be 0, 30, 45, 60, 90, 120, 135, and 150, then 180, then 210, then 225, and 240, 270, and 300, and 315, and 330, and we get back to the beginning, we're at 360. Now, if we look at symmetry of the circle, this 60-degree angle is a reflection of this 100-degree angle, the point. That means that the x-coordinate, distance from the y-axis, is the same from here to here as it is from here to here. So that means it's 1/2 unit from the y-axis, but this time the cosine has to be negative because we're in the second quadrant. So this is the point 1, negative 1/2, positive square root of 3 over 2 because of symmetry of the circle. Likewise, here, this point corresponds to this one. The only thing that changes is the SIGN sign. So the cosine of 135 is negative square root of 2 over 2. The sine is 135 is square root of 2 over 2. You can confirm that with your calculator or the internet. 150, symmetric here, makes this the negative square root of 3 over 2 and positive 1/2. Again, confirm all these values on your calculator. Coordinates here, negative 1, 0. The sine of 180 is 0 and the cosine of 180 is negative 1. Now we go down here and we can again use symmetry. This time the distance from this point to the x-axis is the same as the distance from this axis to this point. That makes this y coordinate a negative 1/2, and the distance here is exactly the same, so we have this negative square root of 3 over 2 and negative 1/2 because we're in the third quadrant now. That makes this one negative square root of 2 over 2, negative square root of 2 over 2 because of symmetry again, and this one negative 1/2, negative square root of 3 over 2. The symmetry lines all these up. So the cosine of 240 is negative 1/2, and the sine of 240 is negative square root of 3 over 2. Again, verify with your calculator. Here we go, the point is 0, negative 1, so the sine of 270 is negative 1, the cosine is 0. Again with the symmetry, straight down, has the same symmetry, gives us 1/2, positive now because we're on the right side of the x-axis in the fourth quadrant, and the sine is going to be negative square root of 3 over 2. Coming down from the 45-degree angle to 315, and we see that this is going to be the square root of 2 over 2, positive in the fourth quadrant, the x-coordinate, and negative square root of 2 over 2 because we're in the fourth quadrant. And last but not least, square root of 3 over 2, 1/2, so we have square root of 3 over 2, negative 1/2. This means also that any angles coterminal with these will have the same sine and cosine. A 30-degree angle is coterminal with a 390-degree angle. So the sine of 390 is the same as the sine of 30. And the cosine of 390 is the same as the cosine of 30. And that makes the tangent of 390 the same. All the trig ratios are the same for coterminal angles. And that's how we've redefined sine and cosine on a unit circle.